Hello and welcome to this video made by Unimaths Help. I've had an email from a certain Matthew asking for help, and his topic he wants help on is group theory. He just wants an introduction. He sent me a very short email. Nothing wrong with a short email. I will still make him his video. But before I get started, I will assume you have some basic knowledge of number systems. So hopefully you've seen the natural numbers, also known the counting numbers. That's 0, 1, 2, you get the picture. These are a subset of Z, which represents the integers, including the negatives. And this is a subset of Q, the rationals, just every number except for the irrational ones. And they are a subset of R, so just all the real numbers. And finally, these are a subset of the complex numbers. So hopefully these are all fairly familiar, because these would be important before. You need to learn these before you move on to group theory, really. Let me know if you don't know any of them. I'm happy to explain them in further detail. But moving on, I think the first thing we'll consider when learning about group theory is a binary operation. So let S be a non-empty set. And we'll consider a map star mapping from the Cartesian product S cross S to S. And we're going to assume that for all A and B in S, star maps A and B to an element A star B, which is in S. And this condition here is critical for star to be a binary operation. And if these two conditions hold, then star is a binary operation. And this axiom here is commonly referred to as BOP. So now I think we're in a position when we can go ahead and define what a group is. So what is a group? A group is a non-empty set, G, equipped with a binary operation, star, such that a few axioms hold. And the first axiom you can see me writing down now is the axiom BOP, which is the one I've talked about on the previous page. This just guarantees that star is a binary operation. And then we have three further axioms, G1, G2, and G3. And I'll write these down, and then I'll briefly explain them. So I'll just write this a little bit faster. There we go, almost done. Fabulous. So G1 just says that star is associative. And if you don't know what associativity is, then feel free to ask, or just Google it as any other person would. But if you do ask, I'll happily make you a video explaining it and some basic properties. But G2 is identity axiom. That just says that there exists an element E in G, and for all other elements X in G, X star E equals E star X equals X. And I think I'll give an example in a minute of, just to make this a bit more intuitive. Similarly, inverses just says that for all X there exists an element G, for all X in G, there exists an element X star such that X star X inverse equals X inverse star X equals E. So these are the only three things you need to be a group. And if G satisfies these three axioms along with BOP, then it is a group with a binary operation star. There's also another axiom that I'll mention briefly. If also G4, that star is commutative, then G is said to be an abelian group. Yeah, that's my phone. Oh well. Examples. So Z, R, and C under plus are all abelian groups. So in terms of G1, that is plus is associative. In terms of G2, there is an identity element, and that is 0. So 4 plus 0 equals 0 plus 4 equals 4. That's it satisfying the axiom G2. In terms of G3, every element has an inverse. 4 plus minus 4 equals 0, that E element we talked about. So you can see it satisfies all the conditions, and the binary operation considered, the binary operation condition that we have to consider is also satisfied. Well, I think that'll do for today. Thanks for watching. If you've got any questions, comment or send me an email. I'll be happy to take them. Have a good evening. Good night.